The article of the day is Problems with CAP and Yahoo's little known NoSQL system. Now, let's discuss the problem with CAP. CAP is generally described as the following. When you build a distributed system of three desirable properties you want in your system, that is consistency, availability, and tolerance of network partitions, you can only choose two. Already there is a problem, since this implies that there are three types of distributed systems one can build. CA, that is consistent and available but not tolerant of partitions. CP, consistent and tolerant of network partitions but not available. And AP, available and tolerant of network partitions but not consistent. The definition of CP looks a little bit strange. Consistent and tolerant of network partitions but not available. The way that this is written makes it look like such a system is never available, a clearly useless system. Of course, this is not really the case. Rather, availability is only sacrificed when there is a network partition. In practice, this means that the roles of A and C in CAP are asymmetric. Systems that sacrifices consistency, that is AP system, tends to do so all the time, not just when there is a network partition. The reason for this will become clear by the end of the article. If you read it, the potential confusion caused by the asymmetry of A and C is the author's first problem. The author's second problem is that as far as they can tell, there is no practical difference between CA system and CP system. As noted above, CP systems gives up availability only when there is a network partition. CA systems are not tolerant of network partitions. But what if there is a network partition? What does not tolerant mean? In practice, it means that they lose availability if there is a partition. Hence, CP and CA are essentially identical. So in reality, there are only two types of systems, CP-CA and AP. That is, if there is a partition, does the system gives up availability or consistency? Having three letters in CAP and saying you can only pick two does nothing but confuse this particular point. But the author's main problem with CAP is that it focuses everyone on a consistency availability trade-off, resulting in a perception that the reason why NoSQL systems give up consistency is to gain availability. But this is far from the case. A good example of this is Yahoo's little known NoSQL system called Peanuts in academic community, or Sherpa to everyone else. In thinking about CAP the last few weeks, authors felt that it has become overrated as a tool for explaining the design of modern scalable distributed systems. Not only is the asymmetry of the contributions of CAP is confusing, but the lack of latency considerations in CAP significantly reduces its utility. To the author, the CAP should really be PACL C, which is the partition. How does the system trade off between availability and consistency? Else, when the system is running as normal in the absence of partitions, how does the system trade off between latency and consistency? Systems that tend to give up consistency for availability when there is a partition also tend to give up consistency for latency when there is no partition. This is the source of asymmetry of the C and A in CAP. However, this confusion is not present in PACL C. For example, Amazon's Dynamo and related systems like Cassandra and SimpleDB are PAEL in PACL C. Upon a partition, they give up consistency and availability, and under normal operations, they give up consistency for lower latency. Giving up C in both part of PACL C makes the design simpler. Once the application is configured to be able to handle inconsistencies, it makes sense to give up consistency for both availability and lower latency. Fully ACID systems are PCEC in PACL C. They refuse to give up consistency and will pay the availability and latency cost to achieve it. However, there are some interesting counterexamples where the C's of PACL C are not correlated. One such example is Peanuts, which is PACL or PCEL in PACL C. In normal operation, they give up consistency for latency. However, upon a partition, they don't give up additional consistency. Rather, they give up availability. In conclusion, rewriting CAP as PACL C removes some confusing asymmetry in CAP, and in author's opinion, comes closer to explaining the design of NoSQL systems.